Alright, I've received a lot of questions about this one problem in particular, so I'm going to go ahead and make a little quick video of it. I've already wrote out most of the stuff so we don't get boggled down by it. I just want to talk about the problem. So, a ferry will safely accommodate 73 tons of passenger cars. Assume that the mean weight of a passenger car is 1.7 with standard deviation of 0.7 tons. If a random sample of 39 cars are loaded into or onto the ferry, what is the probability that the maximum safety will be exceeded? So in other words, what we're trying to figure out right now is what is the probability that X, the total weight, will exceed 73 tons? Alright, so right now we're dealing with normal curves, so I'm going to draw a normal curve, and I'm going to identify the things that I have. I know my mu, which is 1.7 times 39. That gives me 66.3. That's my average weight. Sorry, that's my total average weight. Alright, so for 39 cars, each one weighs approximately 1.7 tons to give a total of 66.3. That's my average total weight. And I do the same thing with my standard deviation. It's 0.7 times the 39 cars, giving me an average standard deviation of 27.3. And because this is a sampling problem, notice the word sample, I have an n which is 39. So there's only one other bit of information, and that was the 73 tons. That's my x value. So they want to know what's the likelihood that x will exceed the 73. Alright, now exceed means I'm going to shade to the right, and of course that's a probability. This is important for when I decide to plug this in on my calculator. Now, the way we do this traditionally is we're going to transfer this over and get z-scores, okay, and because we're doing sampling to calculate the z-score, z is equal to x minus mu divided by sigma divided by the square root of n. Alright, anytime you have the word sampling, that's what the bottom's going to look like until you have smaller samples and we're doing t-tests, but then it's very, very similar. Alright, so here we go. Over in the z world, we know mu is 0, we know sigma is 1, and z, right, is just our x value translated over into the z world. So it's 1.53. And that probability, right, the same probability is translated as probability z is greater than 1.533. That's what I would have gotten when I plug in all those values into this equation. That gives me the 1.53. So there's two ways to plug this into your calculator. Alright, so we know it's going to be norm CDF because we're getting the area under the curve of a normal thing. And we can plug this in as start, comma, finish, mu, sigma. Alright, that's the format we always use. Now, using the z-world stuff, alright, it's norm, CDF. We started at 1.53 and we're shading everything to the right, so it's 1.533. And then instead of using infinity on the calculator, I'm just going to plug in a really big number. So how about 10,000? My mu is 0 and my sigma is 1. Plug that in, and I'm going to get 0.063. Now I'm going to do the exact same thing, and this is a little bit faster, and that's the advantage of using the calculator. It's norm CDF. Now, I started at 73. I'm ending, again, at infinity, but I don't plug that into the calculator. So I'm going to use, again, might as well use 10,000. As long as 10,000 is a large multiple of the standard deviation. I think 10,000 is a large multiple of 27.3, so we're fine. Our mu, 66.3, and our standard deviation is 27.3 divided by the square root of 39. Yeah, there's no avoiding that. We're going to have to plug this stuff in anyway. One is we do it in z-world, one is we do it directly, and when we plug it in we get 0.06 0.27. Again, the numbers are going to be a little bit off, but it's fine. It has to do with where rounding happens. But this is it.